In this video, we're going to go over lines of symmetry, also known as lines of reflection. Alright, line of symmetry can be defined as a line that passes through the center of a shape and divides that shape into two identical halves. Our key here that we really want to focus on is the term center, right? It goes through the center of a shape. So if I was to plot a point to be the center of the shape, let's try that again. We could say that is roughly the center of our shape. So whatever line I draw through to be my line of symmetry must go through that center point. Now, the other component is that it needs to divide our shape into two identical halves, right? So wherever that line goes, it needs to be cut right in half. I want you to think back to, the old elementary school times when you guys were going to school for Valentine's and you had to make paper hearts, right? What do we know about how we used to make paper hearts? Well, we know that we used to take our paper and we used to fold our paper in half. And when your paper was folded in half, let me get rid of that. Let's erase this part. When your paper was folded in half, what you would do is then cut this shape, if you guys recall, and then when you open your paper back up, it would have the matching symmetrical side, and you'd have the crease down the middle, and that crease tells you that everything that's on this side is exactly the same as what's on this side. Obviously, my drawings being quite imperfect there. But a line of symmetry in our shapes works just the same. I'm going to take a line tool here, and I'm going to draw a line. It may not be perfect first, but then I can move it around. So here is a line, and it's going straight through the center of my shape, through this point, and it's dividing my shape into two identical halves. If I was to be able to actually manipulate this shape, if I could cut it out, I would notice that this half could be folded over and directly match on top of this half. Now, there are many shapes that have many lines of symmetry. So just because we found this one doesn't mean that we found them all. This quadrilateral, being a square, has many lines of symmetry. I found this vertical line of symmetry, but I could also find a horizontal line of symmetry. And I know that's a little crooked, so let me see if I can adjust that a little better. There we go. This is a horizontal line of symmetry. If I was to fold this square along that blue line, I would have two identical halves. Now, squares have a special property, and that's that all four angles and sides are the same. So I could take yet another line, and I could go through the diagonals, right? And again, noticing that all of my lines of symmetry are passing through the center. Then let's take one more line. Let me actually change this color so it's a little darker here. Is it gonna let me? There we go. It's too close to my original shade. And then I'm gonna draw that, obviously not quite right yet, but I can now move it. And what you notice here is I was able to draw 4 lines of symmetry, or 4 lines of reflection. Each one of them on their own passes through the center and divides the shape into two identical halves. The diagonals create these triangles that, when folded over, match the triangles on the opposite sides. So we would say that a quadrilateral, such as this square, we could say that it has 4 lines of symmetry, right? We have 1, 2, 3, 4. Hopefully doing them in different colors was helpful. Now, this is different for other quadrilaterals, because quadrilateral, if you recall, is just the term for a shape with 4 sides. Let's take a look at another quadrilateral, this one being a rectangle. We know that it's a rectangle because of multiple features. We know that it has 2 sets of parallel sides, and it's got 4 right angles. And we know that the correlating parallel sides also have corresponding lengths. So let's take a look at our rectangle and determine how many lines of symmetry does this shape have. Again, I'm going to do my best to plot a point in the middle here. Again, we could do a little better. Let's try that. Let's call it that. It could be a little off. We'll see here. Maybe I can actually move it this way. That's locked. That's okay. So let's take a look at our first line. I'm going to go vertical like I just did in my square and draw a vertical line straight down. And what you'll notice is I've created two halves. All right, two identical halves. This actually needs to be more that way, which means my point, let's redraw my point here. We'll call that good. So I have two identical halves here. If I was to fold this half over onto this, they would overlap each other. They would be the same. There's another line of symmetry going horizontal through the rectangle like this. And again, it's a little off, so I'm going to move it. There we go. And what you'll notice is this time I'm folding it vertically. If I took this top piece and folded it down on top, it would overlap this. So two lines of symmetry. Now, in the square, we were able to go diagonal. Whoops, that's the draw tool. Here we go. We were able to go diagonal in the square. I'm gonna, obviously it's a little off, I'm gonna raise it up so that it can be a little better in the corners here. There we go. Now, what you're gonna notice is this may look like it's a line of symmetry, because if you notice the two triangles that it creates, right? The first triangle being right here, a right triangle, and the second triangle being the one down below, you'll notice that the two triangles, they look the same. So this must be a line of symmetry. However, when you fold them over the line of symmetry, what you'll notice is this one would fold like this. And you would have this whole piece right here that is not on top of the other triangle. So what we're saying here is this is not a line of symmetry because it does not fold perfectly like how half of a heart would on a piece of paper if you were to cut that out. That's my poor attempt at half a heart. So a diagonal, right, would not be a line of symmetry. So what we're left with are two lines of symmetry for the rectangle. There are two lines of symmetry. All right, here you see we have two different types of triangles. Each of these triangles is different from the other, just like our two quadrilaterals we just worked with were also different from one another. All right, the first type of triangle we have here is an equilateral triangle. All three of its sides and all three of its angles are the same. Now, this type of triangle has different properties than its neighbor here, the isosceles triangle, because you notice in the isosceles triangle, two of the sides are the same and two of the angles are the same, but not the third angle or the third side. So because they're different types of triangles, you can actually have different types or different amounts of lines of symmetry. So let's look first here at our equilateral triangle. If I was to take my line tool, I could draw a line straight down the middle of my equilateral triangle and have this line of symmetry. But an equilateral triangle lets you actually do that on all of the sides. I have a line of symmetry here, and I have another line of symmetry here. So this equilateral triangle actually has three lines of symmetry. However, the isosceles triangle has different properties. And if you were to draw lines through its line of symmetry, it's standard practice to start by just going vertically down from the top. Let me actually fix this, adjust this, slide it over. We could see here, this divides our triangle into two halves. So we have a line of symmetry here. But if I was to draw a line of symmetry from the other side, just like this, you'll notice that the two pieces that it's created here, let me outline them in different colors. This piece right here creates a triangle, and this piece right here creates a triangle, but they're not even the same shape. So this is definitely not a line of symmetry, meaning that a corresponding line through the other angle would not be a line of symmetry either. Now this shape also does not have any lines of symmetry through its center this way, because if you notice, it creates a triangle on top and a trapezoid on the bottom. So if you were to fold it over, these definitely would not match. So this isosceles triangle only has one line of symmetry. Whoops, I just deleted the wrong thing. Let's try this again. There we go. This isosceles triangle only has one line of symmetry. So even though they're both triangles, they're different types of triangles. And because they're different types of triangles, they have different numbers of lines of symmetry. All right, here we have a hexagon. Now a hexagon has 6 sides to it. All right, and because it has 6 sides, another feature of a hexagon is that all 6 of the hexagon sides are congruent to one another, at least in this hexagon, and all 6 of its angles are congruent to each other as well. All right, so this hexagon is a perfect hexagon, right? All of its sides and angles are congruent to each other, which means we have a lot of potential for lines of symmetry here. Let's start right down the middle. There we go, a line of symmetry that cuts and creates 2 trapezoids. We could go across this way. Now you notice the first one we did down the middle ran through 2 vertices, where this one runs through 2 sides, right? The difference between intersecting through vertices versus intersecting through sides. Now we can continue moving through our hexagon knowing these 2 tidbits of information, knowing that I was able to create a line of symmetry by going through my vertices. I could come through to my other vertices to see if they make lines of symmetry as well. Let's try from this vertice to this vertice. There's a line of symmetry. Let's choose a different color. From this vertice to this vertice. There's a line of symmetry. If you notice, all of my vertices now have lines of symmetry going through them. Now let's look here. The yellow line of symmetry goes through sides. So let's draw another line. What color haven't I done yet? And let's go through some other sides. There's a line of symmetry. I have to get even a new color yet again. Let's change color one more time here. Let's go with like this purple. Oh, that's yellow again. We wanted a new color. Here we go. Here is another line of symmetry. So something to denote is that all of these points also cross through the middle. They all cut our shape completely into 2 identical halves, and they all intersect through the center of our shape. Now let's go through and let's count how many are. Hopefully using different colors was able to help us here. So we'll start here with black. So we have 1, 2 at purple, green is 3, yellow is 4, blue is 5, red is 6, and we're back to black, purple, green, yellow, blue, red. So there are actually 6 lines of symmetry, which is kind of befitting because it's a hexagon, which represents 6 sides. All right, let's talk about a rhombus real fast. Now, this was a neat visual that I found online with rhombuses. And that is that a rhombus, let's go that route, doesn't actually have a line of symmetry. If you notice, if they cut through the diagonal, like one of our other shapes, the rectangle, it created 2 triangles that look the same, but when you fold them along the line of symmetry here, you notice that the corners overhang each other. So it is not a line of symmetry in this example. Here, they went through the diagonal the opposite direction, and they ran into the same issue, corners that overhung, so not a line of symmetry. When they drew a line through the middle horizontally, and they flipped the bottom piece up on top, again, corners that overhung one another, not a line of symmetry. And then when they did a vertical line down the center, and they folded it over, that reflection makes it way off. They actually have, this has the most amount of space that is not overlapping one another. So also not a line of symmetry.